Good morning, everybody, and thank you for joining me. My name is Spencer Allingham. I'm the Technical Director for EMEA for Condusiv. And I'd like to take you through today the new version of V-locity 7. I say new, but it has been out a little while now. But I know that there are still some customers out there who are running older versions of the software. And what I want to do really for you guys is a live demo of what you can expect to see when you upgrade to V-locity 7. There's a few slides that I want to go through first, but I know everybody hates PowerPoint, so I'm not going to dwell on that too much, and I'll try and get onto the live demo. But if it's all right with everybody, what I'd like to do is keep this nice and informal. If you have any questions as we're going through, feel free to use the Q&A box in the WebEx session or even the chat box, and I'll be more than happy to take questions at the end, and we'll have a little technical Q&A, and we can get as technical as you like, or keep it high level if you would prefer. But yeah, please put any questions that you have in those boxes, and I'll go through them at the end. Okay, so now most of you shouldn't need this slide. This is really about us as a company, so I'm not going to bore you by going through all of the details on here. There's far too much writing for a slide deck slide, in my opinion. There are actually a couple of things worth mentioning, though. First of all, as you probably most of you know, we have been around since the early 80s, so over 35 years. We originally started creating software back in the old VAX VMS days, and really started writing software for Windows in the mid-90s when Microsoft bought out Windows NT. And because it was based very much on VMS, and they knew they had some performance issues with fragmentation at the time, they came to us and we worked with them and actually wrote the move file API that's still in Windows today, still in Windows 10 and Windows Server 2016, that actually controls the movement of data around an NTFS volume. So we have a very deep understanding of how NTFS works and really how best to optimize it to get the best performance. And it was really for reasons of performance that Gartner gave us that cool vendor badge several years ago now for what we were doing in the virtualization space. Specifically for when people are running Windows VMs in VMware and Hyper-V, and sort of improving the performance there. Some of the technology also gets OEM'd to a lot of the main hardware manufacturers. You can see some of them listed down here: Samsung, HP, Dell, Lenovo, SanDisk, Western Digital. Typically what they do is use the caching part of our technology, which I'll go through in more depth because it is quite relevant to V-locity 7. And they use that to make their products not only run fast, but stay running fast. So for example, the storage guys, SanDisk and Western Digital, they were using it. One use case was for their hybrid drives, where you have a drive that's part spinning disk and part SSD. They used the caching technology to figure out what the hot blocks of data were that needed to be on the SSD part to give the system the best performance. And others like Samsung, HP, Dell, and so on used the technology to make their high-end ultrabooks and laptops run very, very fast. Now, one thing that, the final thing that I'll mention on here that I'm really pleased about and quite proud of is this Microsoft SQL Server I/O Reliability Certification. Now, this basically is Microsoft certifying V-locity for use with SQL Server. And they ran some tests in Azure when we jumped through all of the hoops that were required to get the certification and prove that it's perfectly safe and also beneficial. So it was nice to be able to do that and get the certification. And I think still now we were the first, but I think we're still the only software-only vendor to have achieved that certification. I think the other guys that have got it are more the storage vendors. So yeah, very cool to get that. And I know in the testing we were testing it with SQL 2016 in Azure, running an online transaction processing type workload with obviously a SQL backend. And we were able to show that with just a small amount of memory for us to cache with, they were able to get 30% more SQL transactions done out of each SQL instance per hour, per day. And that directly equated to about 30% more online transactions processed by each SQL instance, which is very cool. If you're somebody like an online retail store and you know you need to spin up more SQL instances at peak times, like maybe Christmas or the lead up to Christmas, if you can get more workload processed out of each SQL instance, well, maybe you don't need to spin up as many SQL instances, which is important if you're running in the cloud from a price point of view. Anyway, that's enough about us. What I want to do is just quickly address the elephant in the room. Some people who've been running older versions and kept them running for some time will still remember us as a defrag company, and we were for many years. But that changed probably about 4 or 5 years ago now, if my memory serves me correctly. And the reason being is the old school method of defrag really isn't something that you want to be doing in many of today's environments. If you think, for example, if you've got a volume that's a terabyte in size and you're going to do an old school defrag on that volume, what's basically happening is your software is looking for fragmented files on that volume so that it can make defragmented copies of that data, hopefully at a lower logical cluster number, a lower LCM than the original, so you don't bloat a thin provisioned volume unnecessarily. And not all old school defraggers do that, by the way. But yeah, so you're making that defragmented copy, then you use a checksum to make sure that the data that is in the copy is exactly the same in every way as the original, and if that all checks out, then you remove the original fragmented file and leave that defragmented or now contiguous or unbroken file in play. Now, if you've got a volume that's a terabyte in size and you run a pass like that over the entire volume, bringing pieces of files back together again, that causes an awful lot of block level changes. And that is going to cause an awful lot of overhead, unnecessary overhead, to change block tracking technologies like snapshots, copy on write, deduplication, and these are very commonly used in today's environments. We realized this some years ago and thought we need to stay relevant. We can't just rely on our defrag heritage. So today's version of the software, and in fact the last few iterations of the software, have focused not on defragmentation, that's really a thing of the past now. It focuses much more on storage I/O reduction and adding performance, squeezing the most performance out of your systems to make those storage hungry applications perform really, really well. And by those applications, some examples could be things like SQL Server, Oracle, SAP, Microsoft Dynamics. Maybe you've got some file and print servers in there. Really, any application that's generating a lot of storage I/O traffic, that's really going to benefit the most from this type of software. It's not a silver bullet for all situations. If you've got something like a DNS or a DHCP server, well, they're not actually generating a great deal of storage I/O traffic, so there's not really a lot for our software to do. But where you have those busier systems, which tend to be the workloads that you're going to care about the most, maybe a SQL Server that's the back end to one of your main applications, or maybe your CRM or something like that, or a document management system, or your payroll system, when you're processing the payroll reports and want them to complete as quickly as possible. That's really where this software can shine. So I'll explain a little bit about why Windows is not so efficient about dealing with the storage, what we can do to fix it, and then I'll show you a live demo of the software so that you can see what the new features are in V-locity 7. and why you should download it. Now, one thing that's worth mentioning before I continue is that actually one of the new features that, again, we're really pleased about and has received a lot of praise from other customers is the fact that you don't have to reboot now in order to install the software or upgrade. That's assuming that the version you're currently running isn't really so old. So for Velocity 7, you can do an in-place upgrade from Velocity 5.3 or later. So if you're running 5.3 or any iteration of Velocity 6, you can just upgrade the software. You don't have to reboot it. Any live running workloads will stay live, uninterrupted, and you will just be using the latest technology with all of the latest caching engines and so on, without any disruption whatsoever. Very cool. I will go into that in a bit more detail in a bit, but for now, let's talk about why Windows is inefficient and what we can do to help it. So on the screen here is a rough representation of a virtualized environment. You've got your hypervisor sitting here in the middle. It could be a VMware ESX server or a Hyper-V server or KVM running in Red Hat or Citrix Xen servers, whatever the hypervisor technology is. That's it there, sitting in the middle. It's hosting a number of Windows virtual machines, which are running workloads like SQL, SharePoint, maybe web servers, other types of database servers. They're all generating storage I/O traffic, so that's reads and writes going out to disk. They get funneled through that physical host, through that hypervisor, and then onto the storage at the back end, which in a virtualized environment is typically a SAN of some sort. But the same thing happens if you're running physical Windows servers with direct attached storage, or maybe you've got direct attached storage sitting here in the physical host hypervisor. Again, that doesn't matter to our software because we do everything up here at the Windows layer, so that everything below that point benefits, and I'll show you how. So this is what it looks like basically when everything is working well and running efficiently. And by that, what I mean is you have the least number of storage I/O packets, each carrying the most amount of data. So why is that efficient? What it means is that that data can travel down with the least number of storage I/Os down to the storage controller. The storage controller then receives that data in nice large chunks at a time, and it gives it the opportunity to create nice large unbroken stripes across its media, whatever that is. Maybe it's flash or SSD or spinning disk like SAS drives or SATA drives, but it'll create nice large unbroken stripes using the least number of storage level operations before it can then acknowledge that I/O request and send that acknowledgement back up to the Windows OS. So this is very efficient, but when you're running Windows in these virtual machines, unfortunately, this is not typically what you're going to see. What you'll see will actually look more like this. What's happening here is that same amount of data is being split into many more, much smaller I/O packets. And this adds an overhead. This will tend to increase latency, increase I/O queue depths, and basically be bad for system performance. What's happening here is the Windows free space in these NTFS volumes will get more and more broken up over time into smaller and smaller free space extents as you and your applications create more files, delete files, extend files, and move files around. It's that free space that will become more and more split up. So what happens is the Windows write driver is being given a right to perform, for example. It goes to the Windows free space cache and says, hey, free space cache, where's my next available free space extent? I've got a write to do. It gets given that address, it starts writing, and then finds, oh, wait, there's not actually enough room to complete this write. So I'm going to split the I/O. I'll send the data I have been able to write on down to the storage. I'll go back to the Windows free space cache, find my next available free space extent, and I'll continue writing there. So it does that, it continues writing, and then finds, oh wait, again, I still don't have enough room, so I'm going to have to split the I/O again, go back to the Windows free space cache again, and basically repeat and repeat and repeat until it has been able to write out that data. Now, that's a bit like saying, okay, on this side of the room I have a liter of water, which is my data, and I need to move it to the other side of the room, which is where the storage is. Well, basically, it's a lot more efficient to make one trip across the room with a liter-sized jug than it is to take that same amount of water and pour it into little shot glasses, and then take the first couple of shot glasses across the room, and then come back and take the next couple of shot glasses across the room, and then come back and take the next couple of shot glasses across the room. You see how these small shot glassed I/Os carrying small amounts of data make this whole infrastructure work so much harder than it needs to process that same amount of data. So from the point of view of the storage controller now is only receiving this data in very small chunks at a time, giving it now the opportunity to only create very small stripes across its media, because it typically won't understand the relationship between these small packets that it's receiving. So it's only creating these very small stripes. It means a lot more storage level operations are required before it can process all of that data and send the acknowledgement back up. Because the data is being stored in very small stripes, it means a lot more storage level operations are also required if you need to read that data back in later on. So as far as performance is concerned, this is really quite terrible. This is not what you want to have at all. What you want is this type of situation. Now, I heard a really good analogy from one of my colleagues over at head office in California just recently, and I thought it was brilliant, and I made a mental note to share it with you. What he said was, think about this transfer of data between server and storage, like dumper trucks moving dirt from one place to another. What you don't want is to have one shovel worth of dirt being put into the back of each dumper truck. You could have as many dumper trucks, and by the way, the fastest dump trucks in the world, but that's still a really inefficient way of moving that dirt or that data around. What you want is to have each dump truck as full as possible of dirt, or each I/O as full as possible of data for maximum efficiency. And I thought that was quite a good way of putting it. So what does Velocity 7 do to fix this problem? Well, it does a few things. It does a couple of things. First of all, it's a software-only solution still. So you'd install it into these Windows VMs. You don't have to install anything down at the physical host. We don't have to install anything down at the storage layer at all. It's all done up here in that Windows layer where the I/O traffic is generated. Okay. What it does is it adds an extra layer of intelligence to the Windows write driver, so that it can make better choices about where to put that data on the NTFS volume. So instead of having to go back to that Windows free space cache to find yet another free space that's not quite big enough, it'll say, hey, Windows write driver, actually, right here on the NTFS volume, where there is a large enough area of free space to put that data into without having to split it up, or split it up the least. And of course, the software can help to create those nice large areas of unbroken free space as well, quietly in the background, without competing for compute resource with anything else that's running on the machine. So that gets you back to this type of situation where you have far fewer I/Os, but each one is carrying a greater amount of data. Now, a good analogy for that is a busy motorway. You know, if you imagine this to be a busy motorway like the M25 that goes around London. Hopefully you haven't experienced this, but I know some of you will have. At rush hour and other times as well, there is so much traffic on that motorway that congestion builds up and things start running very slow. Now, at rush hour, you've got thousands of people sat in a car. You've got often one person in each car. They're all sitting bumper to bumper, and they're not being able to drive more than sort of 10, 20 miles an hour. And yeah, that is quite a good analogy. What we're effectively doing with our software is saying, okay, if you imagine that each car is your I/O packet and each person sitting in each car is your data, what we're doing is taking the people out of the cars and we're putting them into coaches and buses, and then removing all of those cars from the motorway, getting rid of all of that congestion so that the people, or your data, can now flow to where it needs to get to in a much more efficient manner. So hopefully that makes sense. Hopefully that's a good analogy. Now, what we also do with Velocity 7 is use a RAM caching technique. So we can use some of the idle available memory that's sitting in these Windows machines to satisfy a good percentage of the read I/O traffic. And that's really where the performance play comes in. You know, if you can satisfy a good percentage of those reads from server-side DRAM, not only does that further reduce the amount of workload that has to come out of these machines down the stack and be dealt with by the storage at the back end, but those I/Os can be satisfied at the speed of RAM. Now, RAM is going to be much faster than pretty much any kind of media that you have sitting in your SAN. Even if you've got an all-flash array or you've got a tray of SSDs, server-side DRAM is still faster. You know, it's roughly 10 times faster than flash and SSD. So that is very beneficial to those storage-hungry applications that I mentioned before, like SQL, Oracle, SharePoint, File and Print, and so on. That's great for their performance. What it means is they can now get a lot more work done in the same amount of time, quite simply because they're not having to wait so much on the back-end storage. Now, in Velocity 7, you would have the very latest cutting-edge engines to do the caching and the right aggregation to avoid all these split IOs. So it's worth upgrading just for that. And now that we have the no reboot version, you really have nothing to lose other than the few minutes it'll take you to download the latest version and get it installed. And by the way, if you have a current support and maintenance agreement with us, which most of our customers do, it's sitting there waiting for you to download it. You know, there's no additional cost to get you downloading the latest version. It's already there. It's yours. It's waiting for you to go and get it. If you don't have a valid support and maintenance agreement, well, talk to one of our representatives. You know, give us a call using the number on the website, and we can get you back onto support and maintenance very quickly so that you can get this latest version and really start taking advantage of it. So, yeah, just to briefly recap, we've got these large, clean, contiguous writes, unbroken writes that give you a greater payload of data with every storage I/O operation. We're caching those hot reads from idle available RAM. We've got a benefits dashboard that actually shows the amount of storage I/O time that is being saved. Now, that is very, very useful. This is showing you the time that the storage didn't have to spend basically processing those I/O requests that we were able to eliminate. That's time that's freed up for your systems to now process additional or other workloads. So that might mean SQL is now doing more transactions in the same amount of time, but because you've now got more room in that network pipe between server and storage, it also means that you can consolidate more machines over that same storage and have more machines, more users, more workloads running over that same storage than you otherwise would be able to do. That's quite a valuable thing to have. So I think at this point, what would be good is for me to flip over to Velocity and show you really just what that dashboard looks like. So I've spun up a number of virtual machines here. So this one over here is my domain controller. I've got a Windows Server 2008 R2 machine, a Windows 10 VM, and a Windows Server 2016 machine, all running Velocity. And this machine in the middle is the management console. I'm just going to make that a little bit bigger because I know it might be a bit small for some people. There, hopefully you can see that okay. So this is the Velocity Management Console, or VMC for short. This is the first page that you'll see when you open it up, and this shows you the dashboard data. So my 3 test systems that I have running in my lab, that 2008 R2 machine, the Windows 10 machine, and the 2016 machine, this is all of that data aggregated, or what Velocity has been able to do for those machines, obviously whilst I've been performing my tests, these are not real-world live workloads. These are my test machines that I use for demonstrations and things like that. So the first thing is, and you would have seen something very similar to this if you had already upgraded to Velocity 6, but what you wouldn't have seen are these tooltips here. So these have been put in to explain what each of these metrics are showing. And you can also click on these if you wanted more information, and it will explain it in more detail. And one of the changes that we've put in with these new tooltips is that if you have a machine that is sandboxed or doesn't have an internet connection, then it will pick up that tooltip data from your local install. But if the management console realizes that there's an internet connection there that it can use, it will actually grab that tooltip data from one of our servers. And that means that if we improve the tooltip data or we need to add something to it, we can update that on the server and make it instantly available to you without having to reissue a new version of the software. So hopefully that makes your life easier as well. You can see for things like the total IOs eliminated and some of these others as well, we've now made this context sensitive. So before we had some customers that had eliminated so much IO traffic that it was basically just spooling off the end of the field. So now if we can measure it in millions, as we are here, we will show 45.148 million IOs eliminated from having to go out to the storage. If you have more than that, it'll show billions, trillions, and so on. So this should always be nice and clean and optimized and easily readable. You can see what percentage of the read IO traffic is being eliminated from having to go out to the storage and what percentage of the writes. You can see here I've been doing the testing of the caching much more heavily than I have the write aggregation. Typically, if we can eliminate sort of 40–50% of that read IO traffic, that's really where you're going to start seeing pretty significant performance gains on those busier systems. And as a median average, I would say most customers see somewhere between 25 and 35% of all of their writes not having to go out and hassle the storage. And of course, in the middle here, you can see the amount of storage IO time that has been saved. Now, one question that came up to me a couple of weeks ago from a customer was, I'm now running all flash storage. Am I still going to see storage IO time saved? Because this new flash storage is super fast. I have huge amounts of IOPS. And yes, I'm actually using NVMe storage myself, flash storage, and I'm still saving storage IO time. You know, it doesn't matter how fast your storage is. It doesn't make sense to deal with it inefficiently by putting one shovel full of dirt into each dumper truck, as I mentioned before. You want to make the very most out of that expensive storage, because flash storage is expensive. There's no two ways about it. It doesn't make sense to deal with it in an inefficient manner. You want to make sure you're always going to get the most compute capacity from those systems sitting above that storage. You still have the status alerts in here, and the job queue of the past jobs that have been run. So I've done a few dashboard updates here. Now, new things that are in Velocity 7. If you click on the My Environment page, if you had Velocity 6 or maybe even Velocity 5.3, there wasn't a great deal of data in here. You basically saw the machine names, whether they were physical or virtual, and whether there was a copy of Velocity installed and what version it was. Now you've got a lot more useful information on here. So first of all, each of these column headings are sortable. So I can say, all right, let's show me the machines that are getting the most from the RAM caching. You know, this one has 91% of its read IO traffic eliminated from going out to the storage. So that's a very good percentage. Next one is 70%, next one is 26%. These other ones don't have Velocity installed, with the exception of this one, which is this Velocity Management Console. But it's very easy now to sort these and see which machines are getting the most benefit from having this software installed, and then realize, are these the workloads that I care about the most? And that leads me on to the next thing that I wanted to point out, which is this system status column. Now you'll see some little icons in here, green circles with white ticks in, indicating that velocity on each of these machines I've got it installed on is running just fine, working really well. And on some systems you may find a little orange icon or a red icon. And that's indicating that if it's orange, that the software is working, but it's not working to its full ability. You're not seeing the full power of the software, and it will tell you why. Typically, it's because there's not enough memory free for it to have a large enough cache size for the type of workload that you're processing. So if you've got a particularly read-heavy workload, but you've only got a cache size that's 500 megabytes in size, well, you're clearly going to get more benefit, and more performance by giving it a larger cache size and having more of those reads satisfied at the speed of RAM rather than the speed of storage. So this screen will show you that. If you've got a red icon, maybe it's so strapped for memory that it can't create a RAM cache at all. In which case, you can identify those systems and say, are these systems that I care about? Are these ones that are business critical? You know, is this, for example, the payroll server, and that tells me why the payroll reports have been taking way too long? Or is this my main production SQL server? Now, with SQL, and I'll go into this in a bit more depth because it's quite important. SQL tends to be very memory hungry, almost memory addicted. It will typically, if left uncapped, chew through almost all of the available memory. And what it's doing is using it for its form of caching called buffering. And basically what it's trying to do is stuff as much of its database or databases into that buffer or cache space as it can to try and improve its performance. It does a reasonable job of that, but if you can cap the amount of memory that SQL can take for itself and allow us to use some of that memory, we can do a much better job of utilizing that RAM. And this has been proven time and time again at many, many different customer sites. You know, if you can spare it, leave 16 gigabytes free on a busy SQL server. That would give us a pretty large cache size, and that would be enough to typically eliminate 50% plus of all of the read traffic from having to go out to storage. If you can't afford 16 gig, then give it 8 gig. If you can't afford 8 gig, give it 4 gig. Don't let it sit there on a system that you care about with a cache size that's too small, though, because you're not really going to get the full benefit of the software. You're not going to see just what it can do for that system performance when the cache size is too small. So this will help identify those systems simply with this easy-to-use traffic light system. It'll also tell you if for some reason someone stopped the velocity service, or if there's some problem communicating between the management console and the EndNote systems, so it can't get updates. Now, maybe someone's changed the ports that are open in the firewall, or turned a firewall on that you weren't expecting, and the management console now can't communicate. Well, it'll tell you that. So this is a lot more useful than it was in the previous versions. Now, we took this a step further as well. If I flip back to actually, while I'm on this screen, one thing that some customers don't realize, and I guess it's kind of our fault for not explaining it well enough, but you know, over here, we're showing the Active Directory. Some people don't realize that you can actually expand this out and see organizational units as a tree, which can often make it a lot easier to display the right machines that you want to in here. So yeah, remember that. That's a helpful hint sometimes. Expand those out into the OUs. So let's flip back to the velocity dashboard. At the moment, this dashboard is showing me the data from the 3 systems that I have running, these 3 test systems. I can update the results, and it'll take a moment to speak to those systems and grab the data and display the latest data here. I can change the time frame. So instead of doing it since I installed it, I can say, oh, show me the data for the last 24 hours, or show me the last data for the last week. Every time you change this time frame, it will go out to the servers and will go out to the machines and grab the latest amount of data. So if you have hundreds or thousands of systems, that might take a few seconds. Obviously, I've only got 3 here, so it doesn't matter so much. But I can click on here and select or deselect systems to include or not include in that front dashboard report. Now, typically, you would want to have the report showing you what it's doing on all the systems that you've got V-locity installed on, but you might want to say, show me what V-locity is doing on my SQL servers, or show me what V-locity is doing on my file and print servers. So it's very easy to select and deselect those and see just groups of machines as well. One other thing that you can do is this download benefits. This is again new to V-locity 7. So I can click on this and download this data as a simple text CSV file. So I'll do that and just plonk it on the desktop here. I've got a couple already downloaded, so I'll replace that. And let's go ahead and see if we can open that up. Have I got Excel on this machine? Yes, I do. Excellent. So here's that file I just saved. I'm going to open that up with Excel and we can take a look at it. Okay, so I'll get rid of that. So let's take a quick look at this data. I'll just auto-fit the column width to make it easier to see. So the first row, obviously, is the column headings. And the eagle-eyed amongst you may have noticed, actually, there's more columns here than there were in either on the My Environment page or on that other dashboard page. There is additional information in this CSV file. So, for example, you can see the additional I/O capacity or IOPS headroom that's being handed back to the environment that you can now use for additional workloads. You can see how much storage I/O traffic each machine is producing in gigabytes. How many I/Os are being eliminated, how many I/Os are being generated, what percentage of the reads are being eliminated on each one, how many read I/Os there were, what the size of that read I/O traffic was. The same for writes. And then if I just flip across here to the right, you've got information about the RAM and what we're using for caching. So you can see how much memory on average is assigned to these machines, how much memory is being left available and not being used by anything else, and how much is being used on average for caching with. You can see how much data has been served in gigabytes from the RAM cache rather than the storage. We've put something in there to identify if SQL Server is installed on any given machine. The reason for that is that in those little tooltips, if we can identify a copy of Microsoft SQL Server installed, we can tailor those tooltips and give you some information about capping SQL for best results to make sure that even if you add some additional memory to a machine running SQL, you need to cap SQL so that it doesn't steal that additional memory for itself. Because V-locity won't compete for resource with anything else that you've got running. And it's been designed specifically that way. So if you don't cap SQL and leave that memory free for the operating system and V-locity to use, it would just take it and say, thank you very much, and we still wouldn't get that larger cache size. So by identifying a machine that has SQL installed, we can give you those tooltips that say, yeah, a larger cache size on here would be great, would be really beneficial for performance, but you also need to cap SQL to make sure that it doesn't steal that additional RAM. So let's get rid of that, go back to the VMC. So I think that's pretty much it for the management console that I wanted to show you. I hope that's been useful. One of the biggest new features we feel is the ability not to reboot when you install or upgrade the software. It is super easy to install and uninstall without any disruption at all. Now, this was something that had been a big problem for us, and also a lot of other companies as well. Yeah, I'm thinking specifically like backup companies, antivirus companies, that sort of thing, where they would use, like us, storage filter drivers in order to operate. So you remember I mentioned before about putting that storage filter driver in to give the Windows Write driver that extra layer of intelligence to avoid the split IOs. Historically, the only time that you could load or unload a storage filter driver in Windows was at boot time. And that was the same for us, the antivirus chaps, the backup chaps. It was an issue. It was disruptive to users. Now, we thought for many years that Microsoft have a patch Tuesday, and so people are going to be rebooting their systems reasonably often enough to be able to squeeze in updates and upgrades of our software. As it turns out, we were entirely wrong about that in most cases. People tend not to reboot their servers in a lot of cases every month. Some like to keep them running for longer and schedule maintenance windows less frequently. So that was causing a problem for us for getting people running the latest version, running the latest and greatest, caching engines and so on. So we have a very clever chap called Rick Kadruvi, who's been with the company actually since the inception, right back in the early 80s. What he doesn't know about the NTFS file system, believe me, it's not worth knowing. He's probably one of the 3 people I would consider my technical gurus or gods. He's an extremely knowledgeable chap. So he wrote a storage filter driver manager so that can sit in the storage filter stack and allow us to load and unload drivers now without having to reboot. And I'm really hoping that head office have the sense to patent that, because I'm sure a lot of other companies would like to OEM the technology as well. Hopefully they've got the sense to do that. But yeah, the upshoot of that is that you now don't have to reboot systems to get the latest version installed. It's really simple and easy. I mean, let's see if I can do a live demo of an uninstall. So I'll uninstall from here, which is this machine here. I'll go ahead and uninstall it. So uninstall now. So my uninstall job has been created. That's now running here, uninstalling the V-locity software. And in the past, yeah, that'll take a couple of minutes. In the past, it would uninstall and then say, okay, you need to reboot the machine. Similarly, with an install, it would install and wouldn't be able to do anything and start providing benefit until that machine got rebooted, and then all the drivers could be loaded and it could start work. But now, there we go. The software's been uninstalled. No reboots are necessary. Nothing's come up saying we need to reboot it. If I look here, the software is currently being removed. That service will be stopped. All of those will go shortly. Yeah, completely non-disruptive. There we go. The folder's just been deleted. So now, again, if I wanted to install the software back on here, I can do that. Let's do a fresh deployment. Choose my machine. Save the selection. Use the default configuration policy. Okay, so that's created the deployment job, which is now running. And that software will be reinstalled onto that system again without any kind of reboot. It's as simple as that. It really takes a few clicks and a few minutes to download it and deploy it in that way. Very, very easy. You're all very welcome to get assistance with this. If you want an engineer like myself to have something like a GoToMeeting session or a Skype for Business session with you to actually help you download and get the install done, you're more than welcome to request that. We're always very happy to help customers. Oh, there we go. The software's just been installed back again. The machine's still up, still running just fine. No disruption whatsoever. So yeah, if you want help installing it, just let us know. You can reach out to me personally. My email address, in fact, let me put I'll just stop sharing this and I'll put my email address in the chat box. So here we go. I'm sallingham@condusiv.co.uk. Just post that out. So copy and paste that if you want to send me an email directly. You're all more than welcome to, whether you have questions, whether you want help getting the install done, or even if you've installed, had it running for a week or so, and you want somebody just to check that it's running fine and that you're getting the most value out of the software. Again, I'm very happy to gather some of that dashboard data and spend a few minutes analyzing it to make sure you're getting the very most out of the software, that every last drop of performance out of your system using this type of software. And typically I write an engineer's report which shows exactly what the software is doing now, and if I can make any recommendations, for example, oh, have a larger cache size on this system or cap SQL here, I'll make those recommendations as well. That's been quite popular with customers. So you're very welcome to take me up on that as well. All right, I'm just going to have a quick look and see if there have been any questions or whether I've done a reasonable job of explaining all of this. No, it looks like there aren't any questions. So I would like to finish off then by saying thank you very much for joining this session. I really do hope it's been useful. I would urge everybody who's here, make sure you've got that latest version installed. Get the latest caching engines, get the ability to make sure that you're getting the most benefit out of the software. And if you have any doubts or have any questions, reach out to us and let us help you. That's what we're here for, and that's why you purchased the support and maintenance agreement. It's to get that help and to make sure you have access to the very latest features and the very latest software. So thank you again, everyone. Have a really good rest of the day, and I hope to speak to you all soon. All right, take care. Cheers.